Let me begin by welcoming everyone to this webinar. I think it will be very educational to everyone. As a state agency, we strive to provide the best possible statewide transportation system for the movement of people and goods. Well, this is especially challenging when maintaining an enormous number of bridges in the state, given the level of funding and resources that we have. So in order to meet this challenge, the department continues to select appropriate strategies using innovative approaches, as well as available funds. As such, the department selected this project as a candidate to explore these type of strategies. The project is located on a county road in Boone County in the northeast corner of the state of Nebraska. We sought funds from FHWA Innovative Bridge Research and Deployment Program, known to all of us as the IBRD program, and we were very successful in that. The project features innovative concepts and material technologies which were used under the Everyday Count initiatives. As part of the IBRD implementation, the folded plate steel girders was chosen to be implemented in this project. This innovation features a new and unique concept of dealing with short span, less than 60 feet of steel bridges superstructures. The development of the folded plate bridge system was a result of research that was done at the University of Nebraska-Lincoln, which led at that time by Dr. Azizi. The second feature implemented in this project is the Geosynthetic Reinforced Soil Abutment Integrated Bridge System, known to all of us as the GRS-IBS. This was part of the FHWA Everyday Count initiative as well. Even though the majority of you will discover that it was an expensive project, and some people question really the Department of Roads' judgment of awarding the project, we believed, and still do, that in order to gain experience and expose this type of technology to county officials and others, we believe we made the right decision. We were able to demonstrate that this technology can be built easily using county forces with relative ease. Another feature on this project was the use of accelerated bridge construction, the ABC. The contract of this bridge allows only 30 days road closures. This project also used the pre-poured deck element techniques with ultra-high performance concrete to connect the elements. I will let Fouad and Matt, and they will walk you through the specific details of the design and construction of the bridge. I hope you all find this informative and worthy of your time. Thank you, and I will turn it now to Fouad for the specific of the presentation.
Thank you, Khalil, and thanks for everybody for allowing me to do this presentation. Actually, it was a very interesting project, so to speak. Again, to reiterate what Khalil said, that this project was under IBRD research project, was researched in Nebraska under Azizi Amini, PI, and then we added on it those Every Talk initiative, which is really more or less doing the superstructure will be a folded plate, pre-topped off the side of the bridge with the cast-in-place deck, and build a geosynthetic abutment as an abutment and connect it together with ultra-high performance concrete. I want to present some project facts for this project. This was a school bus route and was designed for HL93 under LRFD design specification. We used for the for the GRS abutment design, we used FHWA GRS interim implementation guide. The calculated scour was 4 feet at the Q100 design, and we checked for Q500 for so if it can withstand Q500. The girder design was the responsibility of UNL under the CRIS contract. meaning the contractor has nothing to do with the design and with the fabrication of the girder or delivery. The girder, the contractor had this contract stipulate that the girder delivery be delivered to the contractor within 150 miles of radius of the bridge location. I know you can see probably clearly this plan, but I'm going to give you a general view of the plan of the profile. You see in the riprap and the width and length of the bridge, which is I will state later. But for this section elevation, the existing bridge only had CMP pipe of 40 inches CMP pipe, and the county stated that every year we have after the rain, the water overtop the bridge, and we have flood there, and we have to close the bridge. So therefore, we needed a bigger area of the bridge or bigger size. So our hydraulics guys came and we selected this size, which is about 58-foot span opening. And this one, we can see that the GRS abutment wings, and we're gonna come back to it. The bridge width, clear width was 24 feet, and overall width out to out was 32. And the abutment, GRS abutment from the wing to wing was 40 feet. And the floor to end the floor was about 58 feet. Overview of the GRS abutment we used is really the typical GRS abutment, like the manuals in FHWA stated, is really consists of the RSF foundation, the GRS abutment with the granule backfill, and the facing, which is we chose to be a CMU concrete blocks. This we used this 7 foot by 5 foot by 7 foot to reinforce, mitigate the scour 4 feet we had calculated, and that was pretty good conservative, but we want to feel good about this technique. We used the minimum spacing of the GRS, the geotextile, which is 8 inches spacing around, all the way up. We doubled the spacing underneath the bearing, and we put double spacing underneath this. Since it's a county bridge, this has no approach slab. This have gravel road. Overall abutment featured the wing and the abutment, the RSF foundation be under the abutment as well as the wings, and it's a U-shaped abutment. It is a low volume road, consists of about 125 volume of ADT with 20% track size, using agricultural vehicles, husbandries, and school buses. Overall detail, I'm going to mention that this is the top of the girder seat we used. We used this cast-in-place girder seat. The top of the wall has to be connected with the concrete with rebars in it, and then the rest of it was a dry stack mainly. And every GRS abutment was going to be laid down all the way to the top of the CMU unit, and then another block would sit on the top of it as a dry stack only, which is we're going to show some few photos. Overall, the girder seat abutment, we're showing here that the cast-in-place girder seat, which is the contractor, we gave the contractor an option if he want to precast it. He selected to have the cast-in-place. Obviously, we will see that the embankment for the gravel road, and that used as well, that's what we call GRS-IBS, which is integrated system. The whole system will be deflected together with no bump at the bridge. And I'm gonna even say here for the superstructure, it is a 4 girder system on folded plate with using cast-in-place concrete. We used the empirical deck design for this one. It's four pieces, 2 exterior, 2 interior, joined with 8 inches closure pools with ultra high performance concrete. And for design of and again, as Khalil stated, the road has to be closed. The contractor had only 30 working days to work with, and the road couldn't be closed till September 15th. So the contractor selected a place for staging area, construction area, about a mile away from the bridge site. And he said that's more economical for him to rent this co-op place to stage his area more than renting and stage his area far away from the bridge. So renting is cheaper than trucking. And for now, I'm going to turn it to Matt to design of the girder. Matt?
Thank you, Fouad. CDR Bridge Systems of Pittsburgh, Pennsylvania was contracted by the NDOR to provide 4 fabricated folded steel plate girders to the job site in East Primrose, Nebraska. Each girder consists of a steel plate which is cold bent into a trapezoidal shape with an opening at the bottom. The composite precast deck and concrete end diaphragm is then added prior to erection. As Fouad stated, based on the span length of approximately 56 feet and the 32-foot out-to-out dimension, this resulted in an 8-foot 4-inch center-to-center girder spacing with a 3-foot 6 overhang. The girder spacing resulted in a 7-foot 8-inch interior and 7-foot 4-inch exterior panel width, and used a 7.5-inch thick deck slat. The 8-inch closure pour did not use hairpin transverse reinforcement due to the use of the ultra-high performance concrete. And as you can see in the bottom picture here, anchor bolts were to be precast into the deck slab for the structure-mounted guide rail. The folded steel plate girders were designed in accordance with AASHTO LRFG 5th edition. For design purposes, distribution factors are based on a refined method of analysis. However, simplified distribution factors are available that give results similar to those of an I-girder. The design live load is the HL93, and live load deflection is limited to L/800. The Boone County bridge used A709 grade 50 weathering steel. However, other corrosion protection methods are available, such as galvanizing, which was done in a folded steel plate girder bridge in Massachusetts, or by metallizing. Section properties conservatively ignore haunch and closure pour, and the design is conservatively based on the girders being simply supported while the deck is being cast, or unshored construction. This is done to accommodate any future redecking. However, shored construction is recommended and was used in both of the folded steel plate girder bridges currently in service. The shored construction minimizes dead load deflection and differential deflection between girders, which will make forming and pouring of the closure pours much easier. Low fatigue detail categories are used in the Boone County bridge. This particular one was a Category B fatigue detail. The folded steel plate girder's wide top flange provides a good work platform during construction too, if needed, as you'll see in slides presented by Fouad later. The wide top flange allows installation of shear studs in the field if needed to meet OSHA requirements for fall protection. And the folded steel plate girder, unlike a standard steel top girder, does not require lateral bracing of the top flange during unshored construction for redecking. Folded steel plate girder has the opening at the bottom, which allows for easy inspection, and it can be used in conjunction with a large skew. The composite girder is compact and designed as a steel stringer. The composite neutral axis is located near the top flange. An additional 10 KSI of stress is assumed in the bottom flanges per AASHTO to account for lateral loads, but since serviceability or fatigue typically controls the design, additional capacity is available. And the folded steel plate girder is torsionally stiff. Intermediate stiffeners, cross frames, and diaphragms are not required. And this is important since differential deflection becomes less of an issue with skews greater than 20 degrees. The as-designed folded steel plate girder typical section used for the Boone County bridge consisted of a half-inch plate thickness, nominal depth of 29 inches, nominal base width of 44 resulted in an approximate 11 kip girder weight. The bearing assemblies consisted of bearing stiffeners, which were also used as forms for the concrete end diaphragms. Shim plates and sole plates are beveled transversely and longitudinally to provide full contact at the bearings, and elastomeric bearings were used underneath the sole plates. Anchor bolts were not used in this application. Instead, it was decided to recess the bearing pads 1/8 of an inch. As I stated, back walls are not required. An 8-inch thick concrete end diaphragm was used to accommodate thermal movement and end rotation, and no approach slab was needed due to the GRS abutments in the approaches. The design resulted in a 57 kip maximum pick weight, utilizing normal weight concrete. If lightweight concrete had been used for the design, the max pick weight would have been reduced to about 35 kips. The fabrication of the plate girders were performed in 4 simple steps: bending, installation of miscellaneous hardware, installation of shear studs, and then the precasting, which was actually done on site. The girders were fabricated at Myco Industries in Ellsworth, Kansas, and the bending required a 3 to 4 man crew due to handling. As you can see in the far portion of the photo, the plate's fairly flexible until bends start becoming introduced into the girder. The girders are cold bent in approximately 2 to 3 hours each, and this slide shows the final bend being introduced into the girder. Then the installation of the miscellaneous hardware, bearing stiffeners, flange separators, and sole plates were installed in approximately 1 to 2 days. And the final step is the installation of the shear studs in approximately 1 day. At this point, the 4 folded steel plate girders were shipped to the construction site in East Primrose, Nebraska on 1 flatbed, where, inevitably, the contractor chose to offload the girders with a forklift and a strap. However, the strap snapped, and he dropped and damaged one of the girder webs. The web was heat straightened without incident, and all 4 girders were turned over to the contractor for precasting. At this point, I'll turn it back over to Fouad to continue on with the construction of the bridge.
Because of that incident, which is Matt, happened, the contractor brought a crane, so he didn't want to use the forklift anymore. So he brought a crane, and he brought the girder to a staging area where he's going to prepare to pour the slab. And he blocked them all to the final elevation of the proposed bridge. And remember, the bridge, as Matt mentioned, this system we cannot camber the girder, so therefore we have to use short construction to prevent deflection. So continuous and yielded support was required per contract. And you can see that we required the contractor to use this wood system over here, about maybe 3 foot spacing area underneath it. And again, he blocked girder elevation for the final elevation. Since the contractor was the folder plate is in use in new technology, he did not know had no idea how to form the deck. So we gave him an idea. That's what the University of Nebraska did in their lab for the kickers outside, and that was good if he wants to use if he wants to use one girder, if he wants to pour the deck one girder at a time. So we give him that's what they use in the lab. Unfortunately, the contractor decided to form the whole bridge as and form it to be poured at once. Therefore, he divided his own system. And you can see that he divided those steel blocks over here to support the plywood and then the girder the deck to be poured over the plywood. And that's what, and for him, that is needed because he needs to access to the bridge right away, because we had him we had him. He has 24 hours only so he can do the ultra high performance concrete connection. So on the right here, we can see that the iron worker already put the iron together and formed. And for the overhang, he just already used the typical shoring, and it was easy for him to do that because the bridge is already on the floor. Obviously, he couldn't do that if he was doing cast in place over the bridge deck. So it was worked out for him. The lifting device provided on the plans was installed, as you can see, but the only problem we had is, as you can see, we had all of them supposed to be oriented this way, so we can have one crane with a spreader beam. But one of the girder had it the other way around, which has prevented using one crane with a spreader beam. So the contractor probably now he wants to use 2 cranes to lift those girders. For the 8 inches connection with using ultra high performance concrete closure pour, we instructed the contractor to use set retardant paint on his forms, so they can be easier to power wash the concrete deck and expose the aggregates. Otherwise, it will be very hard to do. So that's why he was using that form. As I said before, he formed the whole thing deck the whole deck to get the system together, and he needed an access to power wash the edge of the shear key to give us better bond when we're using ultra high performance concrete. For the deck placement, he used a pumper, as we can see, and he elected to use to pour one girder at a time longitudinally over there with the same system. So after he finished one, and he was finishing hand finishing, he only finished hand finished. So he finished the second one, and then come back and he did the third, and he finished that. He put the curing compound, and then came back and put wet burlap. Side note, Nebraska Department of Road, now we changed our policy. We require 10 days wet cure burlap and 7 days curing compound. This is a new policy after this bridge was done. Not because of this bridge, it's because we had a lot of cracks in the past because of the way we were curing our bridges. So with this system, we could easily use 10 days if he wants to. But for this one, he used curing compound and then come back and did the wet burlap. Actually, we had pretty good deck and with hand finish, surprisingly, which is a good thing. In the past project, we did use, during the system, which is closure pool, we had to use headed bars. But that requires us to use 12-inch opening, and because of shrinkage of the concrete mix, we had to use an overlay. In this particular project, the attractiveness of the ultra high performance concrete is they have very low shrinkage according to the research. So we used 8 inches only instead of 12, and the rebars was easily connected together, as you can see. Unlike the previous one, which is we had very hard time connecting the headed bars together. So as you can see, this system is clean, and at least we want to try our own to say we can use it on different application. So that's the geometry of it's a shear key with 8 inches opening. Meanwhile, the crew was working on the abutment, on the GRS abutment. Before they start, while they excavated for the RFS, the foundation, we had 4 inches of rain that day before that, and the contractor was instructed to remove the unsuitable soil, typically like we do on spread footing. So he removed all the unsuitable muddy. Oops, I do. What happened?
Desktop password.
Sorry guys, I have connection problem here. Okay. Sorry about that. Okay, so the contractor removed all the unsuitable soil, and he just laid down all his geosynthetic reinforcement as we instructed him, and then start filling with the granule backfill. And this granule backfill is Nebraska aggregates, which are round aggregates with 38-degree phi angle. So it was pretty good for us, and using our own aggregate for Nebraska. So now, after he already was filled this RFS and compacted to 99%, he will be folding the whole thing together as a burrito, we call it, and then we'll have our reinforced soil system. Now, after he's done the footing, he started laying out the first layer for the wall, and it was very important for him to use the first layer to be straight, and he used half-an-inch sand layer to help level the first block of the wall. And after this, here the first block is already done, and you can see the top of the RFS, the footing. Now, next step, he will fill this area over here with 8 inches of granule backfill and lay it on top of this unit, CMU unit, and we'll compact it, and we'll do the second layer. So he will continually go and doing that. Here he finished about 3-4 layers, and you can see that's the work in progress. On the right side here, we'll see the abutment is done, and at least our estimate for the working was it took him about 1 hour for each layer. I think it's probably that he wasn't going that fast. We think he could do faster, and he mentioned he can do the 2 abutments together if he has to, but he said he can make the 30-day closure. Nevertheless, here we can see the 2 abutments are finished. Here we're showing the wall has been done, and we're showing the scour line, which is 7 feet from the top of the RFS, or the footing, or 9 feet from the bottom of the footing. And the reason we did that is really for maintenance and inspection. When the inspectors go to the field or will see the red line, they will know that they have to put back the abutment together because we reached a scoured line. So that was a good indicator. Another side note, we used the solid CMU at the bottom and hollow at the top, according to the manual of FHWA. The contractor stated that it was hard for him when he was compacting next to the hollow CMU to keep it straight and level together, so he had to support it. So if he asked if we can, maybe next time we can use solid CMU all the time, and I think it's a good idea to do that. Now we're trying to get the girder deck erection. The contractor used 2 cranes, as I said before, and 4 trucks to remove the girder to the project site, which is about a mile away from the staging area. And then he put it on elastomeric and cast in place girder seat beam. Because he formed the whole thing together, we had very good alignment between units and very minimal differential deflection between them. So that was a success for us, and we like that. Here we're showing the whole bridge deck unit is in place, and it took him about 2.5 hours to erect the whole four girders together. And in this photo also, you can see that we already done the riprap underneath it, and Nebraska used topsoil for the riprap. So you probably don't see it, but it is there. And at this time, I believe we used about half of the closing date already. Giving back, he lost about three days for the rain already. And now all he had to do is come back and fill for the approaches for the county road. For the ultra-high performance concrete, the contractor contracted Ductile from Canada. So they came with their 3.5 cubic foot mixers. We only have 3 cubic yard ultra-high performance concrete to fill the 8 inches closure pour. The representative was on site. We like to have two of them, but we already sent one, and I think we should would be a better idea if we have two representatives instead of one. Nevertheless, all the ingredients were measured for the quality control, and supervisor added over here, and the mixing started. We required by contract to have actually the mix was the responsibility of the ductile company, and they chose a 21 KSI 28 days concrete and 12 days and 12 KSI 4 days, and about 8,000 probably 24 hours. We required that the joint to be overfilled with 1/8 inch so it can be grinded at the end. And we don't, because the self-setting of the nature of the ultra high performance concrete. So that's what they used. You can see over here they're using the chimney to help the matter, and that helps to keep the ultra high performance concrete moving. The spacing of the chimney was about 8-foot spacing. UHPS material had very good flow, so we have any problem with that. Especially we have only 2 inches drop between one end to another, so the concrete was flowing okay. In order to finish the grinding of the 1/8 inch, I used using floor grinder, and it was really a little bit harder than he thought, but he got it done because the concrete was probably about this are probably about 1250 KSI fast curing. So the grinding went well, and using floor grinder. Got a picture here before the grinding and after the grinding. Looks like the 1/8 inch we provided overfill wasn't enough. Maybe 1/4 inch would be better. You can see some settlement of the ultra high performance concrete, and that got some irregularities in joints. But it's not that bad as it looks, but it was okay. So the ductile recommended using non-cement grout to fill irregularities, and we did so. And then we grinded after that one more time, and then we've done that. Obviously, we're required to test for ourselves to see if we have leak or not on the bridge. We did water test. As you can see, the contractor dammed every joint. We had every joint, and then flooded it with water. We made sure that we have enough water for every joint, and then we checked it down, and we had success. We had no water drop whatsoever. Actually, I would be happy with damping if there's any, but we didn't have anything, not even damping. So we think it's a success, and we had no leaks, and that's good material to be used on our closure joint in the past, and we're gonna think about that. Obviously, you can see that this is he used the wood form to underneath the deck to form the closure pour, and then you can see the trace of the after the wood forms. Nevertheless, we have no leak, no damping, no nothing, so we think it's success. Another photo at the corners, you can see this is only for joint for the ultra high performance concrete mix, but it's not damp. So it is good, no leak whatsoever. And during the time we were recording the time lapse, so I'd like to show you the time lapse for this. Pretty neat, huh? And after that, the bridge was open to traffic November 19th, 2014, and the contractor probably used we gave him back 3 days with the rain, so that's why probably more than be about 33 days. So, but we considered fulfilled his contract, and he was ready to do what he needs to do for the bridge opening. Everybody waiting for the cost, and that's what Khalil was talking about. We think we probably have, it was costly project, we can tell, because maybe a lot of innovation in it and familiarity with the contract, the system we're using. We only have one bidder, which was the only contractor he bid, and he got the project. Even though we did advertise and we did have the pre-construction conferences, but looks like nobody was interested to do GRS abutment for some reason or another. So this cost is, as I said, is $455,000 without the girder. The GRS abutment was $265,000. If I compare it to bridge like that, typical bridge we do in Nebraska for county bridges, probably it's double. We can do probably the same abutment with piles and sheet piles and the concrete beam, as typically we use, probably using $150,000 abutment. Nevertheless, this cost of innovation. Ultra high performance concrete cost $200 per linear foot, and we had 192 linear foot because 4 joint on the floor, so it cost us about $38,000. The folded plate girders cost $90,000 delivered to the site, and that was contracted, subcontracted from university to CDR, and he can speak for that. The deck, the concrete for decking is 2,300 per cubic yard. Typically, we use that. We're getting about 1,200 for a far away bridge like this, maybe even 700 on typical state bridges. But that was, you can tell, it's pretty expensive. So the bidding was 2,300, and the total cost of the decking was 108,000. Even the epoxy coating, you can tell, we typically use probably what is our cost about $1.30 a quarter, and maybe for county bridges, maybe far away, maybe $1.50. We can see that the bid was $3 per pound. So overall, the bridge was a little bit expensive that we thought it is, and because our estimate was 400, even that, including the risk with the new elevation, maybe we underestimated it. But that's $400. That was the cost. And I'm going to finish with the conclusion and lesson learned. I'm going to start from the bottom, the contractor impression. The contractor mentioned, we had a discussion with him that it is a very interesting project for him, and he learned a lot, and it wasn't difficult to build. And now he tells us after that, but nevertheless, he said it's not difficult. And if he got to do it again, he'll probably be bidded a lot cheaper. So that's a good thing to know that he was accepting the new concept. But he told us, I'm going to mention that, I don't know, that we discussed that with our Nebraska agency regarding at least the GRS, what they think of it. They were grumbling that they don't want to use this because they are general contractor dealing. They don't want to deal with walls and taking their job away from them, especially if the iron worker already there and they have their crane and they have all this equipment ready to use, and they cannot use it. So really, without using this equipment, it's going to be very expensive for them. So they are against it from the beginning, and we're trying to work together to get them accepted as much as we can. For the RFS, he mentioned that this is the most difficult process for him because we had no room to excavate. And we have no right of way to do that anyway. And the U-shaped abutment, it was bad for him. He would like to see it, if we can, 45-degree or maybe flared or straight wings. So we will consider that in the future. Obviously, for the GRS abutment, he said the type of abutment does not pay for the carpenter, as I mentioned, and the iron workers and the crane operator, and that's why it was expensive for him. At least he thought, and it is untraditional. Forming the deck, the contractor mentioned forming and pouring the whole unit will save time and money instead of pouring individual girder at the time. So that's why he chose to pour and form the whole thing together, and it worked out for him. And really, he could, and for the station area, as I mentioned, renting the co-op place close to the project was cheaper for him to choose further away station area and truck it to the shop site, which is be more expensive. The ultra performance concrete, his comment was painting the foam with the step retarder worked well because when he power washed, it did very good for him. So he liked that idea. He said, but if he had to do it all over, he would use foam instead of for the keyway instead of plywood. It'd be better for him during stripping. But the only thing is waiting for the ultra high performance to reach the 10 KSI required to start grinding. He thought it was too long and too hard to grind. But that, according to FHWA advice, they said it's good to wait 10 or maybe we can go to 8, no less than that, because the aggregate will crumble. So that's what the comment was. And use the floor grinder to grind the joint. For him, he had to come and get those big grinder instead of hand grinding if he has to do it. So that's really what I have for this project. I hope you enjoyed the presentation. I think we had fun and was very interesting. And the county have very good bridge for 75 years. That's our design, so we hope it's going to last 75 years. We have no reason to think otherwise, and that's our life cycle for all our bridges. And now I'm ready for any questions you have.
Okay, thank you, Khalil, Fouad, and Matt, for a very informative presentation on this very interesting, innovative ABC project. Ben Bierman with FHWA will now moderate the Q&A session. Ben?
Thank you, Mary Lou, Fouad, Matt, Khalil. Great presentation, as always. Great project. Folks, we received a good amount of great questions during the webinar and, of course, prior to the webinar. And I've got them grouped for us. We've got those in design, and I broke the ones in design specific to the GRS-IBS wall and the folded plate girder. We got a few on the UHPC as well. We have questions related to construction, performance, and inspection, and of course cost. So we'll go ahead and start with the design ones first, and I'll go into the general design questions too. So Fouad, I don't know if you can answer this one, but why was the bridge selected over culvert alternatives? Why a bridge, or why the folded plate girder?
Well, you know, remember we have a research project, and we were under the research IBRD. We have an implementation, and that implementation has to be for this folded plate system. At least at the beginning, we have to get 60-footer or below 60-foot. Really, we waited a few years to get on the state system. We couldn't find one. And when we get the county one, which is a short bridge, we grabbed it. So really, for us, yes, I agree. If we wasn't life cycle between these two systems, because we want to try. That's an implementation of a new idea, and that's really what happened. Now we know. Now we know if we have to do it all over again, at least we have an idea to and to select the appropriate system for every bridge. Okay. So it's a short tell. We had to use IBRD money for the construction, and that was good. That bridge was for implementation.
Regarding the procurement, did you need to provide more lead time between your advertisement so that the contractor could get his fabrication and his on-site construction activities completed?
Well, you know, for the support, I do have my assistant construction engineer, and he will probably answer the question. This is Jason Bowles from our assistant construction engineer.
We really didn't have any more lead time on the advertisement side than usual. We did have a pre-letting meeting with all the contractors, as Fouad mentioned, and that was about 2 months before letting. So there were some preliminary plans out there at that point, but it was awarded mid-April, and the start date was on the road. Closing the road wasn't until September 15th, but the contractor was allowed to take delivery of the girder on July 1st, so there wasn't a real push on time in terms of that.
Was there a difference? I'm assuming, like your modular block walls, did they have to follow certain specification requirements? From my understanding, it's not just a block that you get out of Lowe's or Home Depot.
Actually, as I said, we used the FHWA implementation guide, and this all stated there. So really, we more or less took all this special provision and the design help from the guide. It's all stated in the guide. So there is a provision there. I'm not going to go there if that's what you're asking. It is all stated in FHWA guide.
Okay, great. So let's we'll move on over to the GRS-IBS, and then we'll get into the folded plate design type related questions. So with the GRS-IBS type questions, why was the polystyrene being used underneath the bearing slab at the end of the folded plate girder?
Well, that was good observation. Actually, what I showed is the one we had it, and then we removed it after that. We had a discussion that would we put the girder, which is heavy, on the top of the geosynthetic soil. Is this going to cause any pushing over the wall? So we were hesitant on that. And after consultation with FHWA, Mr. Adam, and he told us probably we don't need it. We don't need it. So styrofoam was not used. Was removed.
The backfill material choices for the GRS-IBS, from my understanding, it's a well-draining material. Did you guys pick sand over a gravel, or how did you pick your, I guess, backfill material for your GRS-IBS?
You know what? According to the manual, by the way, it regards either select or a granule backfill with a fee angle of 35, if I remember. Luckily, we have our Nebraska got good aggregates with the rounder material with aggregates, and the fee angle we tested it was about 38 or about 35, 38, and we thought was pretty good, and that's what we selected for that. Jason, do you have something to add? Yeah, and that's really what we selected, the granule backfill for that.
Readily available in Nebraska.
And it is readily available for Nebraska.
Great. Okay, this is a good observation too. Somebody noted that there didn't seem to be any drainage behind the wall. Is that good? I mean, do you need to provide weep holes and drainage and things like that, something that you would typically see in a conventional cast-in-place wall?
Again, that's a great question, because great observation, because that's our concern was when we discussed with Frank Adam with FHWA regarding the system, and he assured us that fill was for the road. It will be pushed and against the wall, and water will not come there, according to him. So it is a gravel road, granted, but that was our concern. And Frank, it seems like he said no concern for him. So we left it this way. See what happened. I agree, that's a concern.
And what about, we'll get the geotech question in here, your estimated short and long-term settlements of the abutments. Did you guys have values for that?
No. Yeah, I'm going to talk about the design on that, but really we believe we met all the requirement, and the settlement itself under this was okay. I mean, the only settlement is that's what we have. That's what we call IBS, which is really that flexible. We expect settlement from the bridge, not underneath it.
Okay.
It's not a spread footing.
All right, we're going to bump on down to the folded plate category questions. There's a lot of questions that we already received, and I can see a lot posted onto the website as well. So we'll just start with maybe the geometry. What was the beam seat size? I noticed that you had on one of your very last slides there, which showed the bridge in the final stage. I think you can go back one click. The question was, what sort of beam size, what type of beam seat size did you need at the bearing locations? You might want to go back a couple. And I guess that would be both in front. Whoop, you had it right there. It was that one picture of the bridge. You're going back, I believe. Keep going forward. Keep going forward. It shows the bridge, and there it is right there. So if you look over there at the abutment at the far end of the picture there, you have a corner there with your GRS-IBS, and you also have the beam seat in front of the bearing as well. Was that prescribed for the FHWA's guidelines with the GRS-IBS? And what kind of beam seat width did you have there?
I'm going to check the plans.
The beam seat width per plan was about 3 feet 2 inches behind the CMU wall.
Yes.
The center line of bearing was about midway back there. Obviously, the concrete end diaphragm lines up with the rear of the seat, but I'm not sure if that's question.
I think we have this, and it's about 3 feet goes into this, 3 feet.
Okay.
That's what it's from the wall, and this was. If I go, give me a second here. I think maybe if I understand the question correctly, that was shown in the beginning. Is that what it is?
Oh, there we go. Mm-hmm.
Yeah. You know, we had to go all the way about 3 feet 6 inches beyond the wall, so we can minimize the pressure on the wall, and that's the intent of it. So that's that was in the manual in the guidelines.
Well, stay on that slide there, because we got another good question that relates just to that. Can you explain the bearing installation without the use of anchor bolts?
Bearing installation with the anchor bolt. So why don't we use an anchor bolt?
Yeah, the question is, you know, well, what do you do when there's no anchor bolt?
It's not a seismic area, so really no uplift on this bridge whatsoever. Is anyway, in Nebraska we have no seismic. And
can you hear me?
And really what we do to prevent the walk-in, and the elastomeric would be embedded 1/8 an inch into the concrete, recessed 1/8 an inch. That will prevent the walk-in of the bearing, if that's the question.
Okay, and then you've got the passive resistance of the wall up against your back.
Ben, can you hear me?
Yes, Adirad, we can hear you.
Yep. Let me answer that question. This is a very short span bridge, and thermal expansion and contraction is very small, and it's a semi-integral type bridge, and it's allowed to expand and contract freely. So there is no really need for any kind of anchor bolts in this kind of system.
Okay, thank you, Adirad.
If I could add on to that, Ben?
Go ahead. Sure, Matt.
If I could add on to that as well, I would add that, you know, really this could be used for any substructure. The GRS-IBS, first one that was done was integral abutments. Even now, we're using instead of one solid bearing plate, now we're using two, one contained inside each flange. And we're putting the anchor bolts through the sole plates at the center line of bearing, so when you do need anchorage, you can get it.
You know, Matt, that sort of folds into this other question. We did, I believe, a webinar on MassDOT's folded plate some time ago. Have there been major modifications to the folded plate girder since that presentation to what we're looking at today?
Not for the plate itself or the design, and I mean the one thing and the benefit of it is the fact that there is no welding except at the bearing stiffener. It is one plate that's cold bent, and the cold bend radius is 5 times the plate thickness. So you know, cracking really isn't an issue during the fabrication process. But really, it's just been some tweaks here and there as far as how we're treating the bearings. Maybe using 2 bearings per girder side instead of one continuous one to again allow for the anchor bolts in between. Also, you know, the original one that was done in Uxbridge, Massachusetts had a 13-inch high early closure pour with headed bars, whereas now obviously with the 8-inch ultra high performance concrete closure pour. So, you know, really it's just been slight refinements here and there, and a lot of it's really going to depend on, you know, what state is, you know, being constructed in. You know, every state has their own details, whether it be for, you know, barrier or guide rail, but then that's more of a you know, a deck issue more so than the girder itself.
And can you say a little bit about the design method? Do you use particular software? How do you go about designing a folded plate girder?
Well, again, originally it was developed using finite element modeling and testing, and we have developed a simplified method that we use in-house, and it's probably more based on a line girder analysis. We do have design spreadsheets that are available for the 22 standard sizes, and frankly, you could go to cdrbridges.com and download those design spreadsheets. And it has different girder spacings and span lengths, so you can get various design section properties. But as far as that goes, again, we conservatively use a line girder analysis, but I know in talking with some DOTs in the past, they were worried more about permitting of overweight vehicles, that they may want a more refined analysis, and obviously we can do that as well.
Okay, great. And what was that website again? CDR.com?
cdrbridges.com.
cdrbridges.com. Okay, great. So there was a couple questions regarding bird nesting on the bottom flange below. Are there certain strategies that can be employed to prevent that from occurring?
There is a detail. Maybe we didn't see it. We didn't put it there. We put a plywood to cover the bottom on it. So plywood, and allow the inspector to look inside, but so you can pull the plywood up. But there is a plywood inside the girder. So that's prevent, and that will prevent animals or bird nesting to come in.
Okay. And other things, we could use a mesh or some type of
you can use that too also.
Green.
What do they call it? Screen or something. Yeah.
Okay, a bird screen. So regarding the inspection, or just in service, will the bridge undergo any monitoring in between your routine inspections?
Because we're seeking the help of HWA on the GRS abutment, because that was our concern, because we're not familiar with this, and using the EDC, they were graceful enough to help us monitor it, and they will come every year and look at it, and we'll go from there.
Okay. Here's a good question regarding the design. Was the deck modeled as fully continuous through the longitudinal joint for live load distribution?
Yes.
Okay. And that should be correct. If you're using your UHPC, that's a full moment and shear connection. So
correct.
You should be able to do that. Correct.
And that's the intent of ultra high performance concrete, using 8 inches only instead. We already developed the bars of 6 inches splice. Slab splice.
So how is the open box section made torsionally stiff?
Matt?
Well, just the cold bending of the rough trapezoidal shape, when we have the flange separators at a rough 10-foot spacing to help keep the shape, that's really providing that torsional stiffness and making it treated like a box, particularly when the deck hardens.
Ben, can you hear me?
Yes, Adiron.
Yeah. Let me add to what Matt said. There are separators that are placed in the bottom flanges of the girders that are really meant to provide mainly the torsional rigidity if the unshored construction is used. So the true application of the folded plate uses a shored construction, so you don't really need that. Now, after the live load, after the deck is hardened and the live load comes on, you really do not need anything extra. In fact, that even if you didn't have that separator in the bottom flange, you would be better off. But nevertheless, we leave those in even after the live load comes in. But even if you decided to do an onshore construction, adding those plates, which is every about 10 to 15 feet apart, connecting the bottom flange, it gives you torsionally, it gives you a property that is very close to a closed box, and that's one of the reasons why we do not need cross frames inside the folded plate or between the girders. And that's the main advantage with the system, that you eliminate the need for all the bracing requirements. There's no the need for the top lateral bracing that you need for the boxes. There's no need for cross frame inside the boxes. There's no need for cross frame between the folded plate.
Well, and that sort of answers this other question too, Adirad, is the advantage of a folded girder to other, we'll say, section types, whether they be I-sections or pre-deck sections like next beams and things of that nature.
Yep,
but really,
exactly.
primarily the I-section. Are there other advantages of going with the folded plate versus some of our conventional beams?
One of the main advantage of the folded plate, I think, is the fact that for the ABC, when you use this in conjunction with the ABC, it allows you to use a wider spacing between the girders. And a typical section, typical cross section in a bridge, you will require only 4 folded plate with the deck on the top. So I see that as the main advantage. And I think everything has its own place, I-shape and folded plate, but I think in the ABC application, the folded plate gives you a very good option to use girders every 10 to 12 feet. And that is a big advantage, because the transportation cost and moving the pieces of the bridge from one place to another place is going to be reduced.
And what's sort of the practical span limit for using a folded plate?
At this point is a 60 feet. And that is the reflection of the longest press break that is available.
Okay, and the AASHTO code, does that address some of the code requirements? And
there is no exception to the design provisions that is listed in the AASHTO LRFD bridge design specification. The design of the, like Matt said, the design of the folded plate is 100% in accordance with the AASHTO LRFD bridge design specification, and there's no exception. For the distribution factor, like Matt said, there's an in-house capability that uses the refined methods of analysis, but at the same time, there's also a simplified equation that you can use. So to answer your question, no, there is no exception to the design provision that is listed in AASHTO LRFD bridge design specification when you design the folded plate girders.
okay. So Fouad, this might be a question out to you. If you're going to do another folded plate girder, would you consider a precast deck to reduce your crane size?
Yes, if we have to do it all over, actually that was one of the contractor's comment, and he told us probably the system will be even better, will be help a lot. So if you use a precast deck on the top of that, and that's probably be our move next time we're gonna do something like that.
Okay. So I'll bump on down to some of the construction-related questions. Did you guys experience any concrete cracking during the transport of the beams?
No, the bridge, actually the whole construction went flawlessly. According to, actually my construction guy told me he was very happy. This is the first bridge, he had no problem, and we have nothing, what we call it, money owed to the contractor. So, so we did good on that merely. So we had no, the whole thing was crack-free.
Okay. There's a couple questions regarding the time, and I believe you explained it quite well in your presentation, but the question here was, did the 15 days include abutment excavation, abutment removal, or in this case, your pipe removal, and in that 15-day time period that you guys were coming up with for this particular project?
Yes, the whole thing was actually, I shouldn't be saying that. If we take the 4 days, because remember he did do nothing with was rain, so we gave it back to him. So really, it took him about 15 days. So yes, including the excavation of excavation and putting the riprap under the bridge, the whole thing except the rail. Then, if I remember, I said he used with that slide when he erected the girders and everything, he used almost half. So that will give without the 4 days. So that's 11 days when he did when he finished erecting the girders and putting the riprap under the bridge. That means that photo I have here.
Okay.
Here, he already used about 11 days.
Wow.
And that's including the riprap underneath it, so the whole thing is already excavated and everything. So he actually in this area, in this photo here, he still have to do the closure pour, and he already scheduled ductile to come on Thursday, and this was Tuesday, if I believe. So he had a couple of days to start forming and do whatever he needs to do.
Now, does this bridge have slope to it in the transverse and longitudinal direction?
Yes, it is 2% cross slope and about 2 inches vertical curve, tangent curve, I should say, not vertical curve, from one end to another. So pretty flat, more or less.
Okay. And the beams you all, in this case, and it seems like a lot of the folded plate girders, they're pre-decked in the fully supported condition. So there's just no camber that's put into the beam. Is that correct?
That is correct. We cannot put, because the fabrication, like Matt mentioned, they cannot put camber in for now. We cannot put camber, so that's why it has to be. That's why we went to short construction, as I mentioned.
And in the final position, where
can I add something to that, to the camber?
Sure.
One of the reasons that the folded plate is limited to the 60 foot is that you cannot camber these things. But we have done quite a bit of a study, and the up to 60 feet actually, the deflection due to the log load after the deck comes in is not noticeable at all. And the use of the short construction actually is more for the benefit of the ABC application more than anything else. So if somebody wants to do an onshore basically construction, you can do that. And you can actually, for the profile, you can adjust your hunches. And the use of the short construction, but happens to be the most economical way of building these things, which is also helping us in the controlling the deflection. But deflection is 60 foot span, especially with the rigidity of the sections that is not really a major problem.
Fouad, can you go to slide 20 really quick? And I think that slide 20, it was 19, I believe it is. Excuse me, go back one. Go back one more. 18, 17, keep going back. I thought it was 20. Huh. Well, anyway, there was the picture of where they're placing the concrete onto the deck. With the there it is. There it is, right there. And I believe that picture to the right says a lot. I mean, I don't know if you mentioned it or not, Fouad, but these sections are actually cast individually. So per beam, there's a certain width of concrete deck that's placed, and so all that restraint shrinking is actually relieved while the concrete is being placed. Is that correct?
Yeah, that is correct. There is an 8 joint between the form. There was 8, as you can see on the left side. This is the joint. That's really as individuals. So there is restraint for the concrete, and then you get the 8 and 8 joint gap, and that was formed. That was formed for this photo, yeah, like this.
Okay. And back onto that photo there, that it also shows and demonstrates that this contractor is pouring a concrete deck without having to use full fall protection. He's not, in this case, the ADT isn't very high, but if you were in a high ADT solution, situation with traffic adjacent to you, you're not in that situation. So
I agree, and they did not have to use a pouring machine, Bidwell. I didn't have, actually, we allowed them even to use screening if he wants to. He should chose hand finish, but granted, but screening could have done okay. Luckily, we did that when we did it over the interstate. We had like 160-foot two-span big box. The contractor, the other contractor chose to pour individual every box individually because it gets too heavy on him, and that's what he did. And he uses screening. But he told me it's very safe for him. He didn't have to go over the interstate and safe, and so safety and insurance probably would be minimum for him for next project. And they like the idea of pre-poured over the interstate.
And you all have a 17-day concrete cure period for your decks, correct?
That is correct. From now on, that's our new policy. It's a 10-day cured and 7 days curing compound. So that's really going to be for accelerated construction. If we have to do it with time pressuring us, that's going to be a problem to do this 17 days. So either we have to go to precast or they have to do precast on the side like that.
Okay. Well, folks, we're out of time, so I'm going to leave you with one more question here, and then we'll wrap it up there. There's more questions too, and we'll get those posted sometime about a week or two after the after today. So, Fouad, is this, as an owner, is this a method that you would try again? And do you really see the benefits in the reduced construction time, or these methods of construction where you're doing a lot of your construction activities off-site?
We had this discussion all over the place right now, and we, obviously, now we have one project under our belt, so we can at least say we had some experience. But it's hard to change for the contractor, and without moving with the AGC, with our Nebraska AGC anyway, it was going to be hard. And according, we are promoting it as much as we can, and we believe this, at least I believe, the GRS abutment is really should be suited more for the county, which forces, which is they have their own crew, which is they don't have for Nebraska we do deep foundation piles, so they don't have the hammers, they don't have the all the heavy equipment, so that will suit them for them. But for the regular general contractor, unless we have to take a lot of education to tell them this is the way to go, maybe it would be harder for us. So we are working with the county as much as we can, and with FHWA, and we're going to educate our contractor as much as we can, but we're going to help our county bridges maybe build a couple of those on their own, and that would be the way to go for us.
Excellent, great. It always takes champions, and we'll say that in plural within an organization to help promote those innovative technologies. So with that, Fouad, Matt, Khalil, and Adirad, thank you so much for the Q&A. I'm going to pass the torch on over to Mary Lou, and we'll let her close us out. Mary Lou?
Thank you. Thanks again to Khalil, Fouad, and Matt for your excellent presentation and Q&A session. Thanks also to Ben for moderating the Q&A session. We let it go a little bit longer because we got so many questions that came in. And thanks to each of you for your participation today and your many questions. As mentioned earlier in the news presentation, if you received an email notification that your 2015 National ABC Conference abstract was accepted, please respond to the email by tomorrow's deadline. This concludes today's webinar. We look forward to your participation in our next webinar on Thursday, July the 23rd. Thanks again, and goodbye.